Exponents, just the basics. Just to be clear, the video that you're watching is part of a series designed to help students who are preparing for the SAT and who are in trouble, who need some assistance to get from a bad score to a pretty good score. With that in mind, the following section is going to take a very simple view of exponents, and we're going to leave out quite a bit. To put it simply, this is not everything you need to know about exponents on the SAT, but it is most of what you need to know for the easy problems. We're going to cover one definition, two rules, a bunch of examples, and a few problems. What we're going to define is a power. You've all seen powers before, like 9 squared or 5 cubed. The big number in the power is called the base. The small number that's up in the right-hand corner is called the exponent. You find the power of a number by multiplying the base times itself however many times the exponent tells us to. Here are some examples. 9 squared, that is base 9, exponent 2 equals 9 times 9 equals 81. 5 cubed, that's 5 to the third power, equals 5 times 5 times 5 equals 125. 3 to the fourth, that's base equals 3, exponent equals 4, equals 3 multiplied times itself 4 times. 3 times 3 times 3 times 3 equals 81. 2 to the fifth power, that's 2 multiplied times itself 5 times. 2 times 2 times 2 times 2 times 2 equals 32. One base that we see a lot is 10. And the nice thing about working with base 10 is that you can see the exponent by counting the zeros in the power. For example, 10 to the 6, in other words, 10 multiplied times itself 6 times, will give you 1 million, which has 6 zeros. Now let's talk about the two rules. For starters, if you multiply two powers together that have the same base, that part about having the same base is very important. But if you multiply two powers together with the same base, all you have to do is add the exponents. So for example, 2 squared times 2 to the third equals 2 to the fifth. 3 to the second times 3 to the second equals 3 to the fourth. 10 to the second times 10 to the fourth equals 10 to the sixth. The second rule concerns what happens when you have a power of a power. In this case, you multiply the two exponents together. Normally this looks like this. You have a parentheses. Inside the parentheses you have a power, and outside the parentheses you have another exponent. For example, parentheses 2 to the third, close parentheses, squared equals 2 to the sixth. You can confirm this by actually plugging these numbers in. 2 to the third is 8. 8 squared is 64. 64 is the same value you would get if you multiplied 2 times itself 6 times. Remember how we got 81 twice in our examples earlier? This is why that happened. 9 is 3 squared, so 3 squared equals 3 to the fourth equals 81. The SAT will frequently give you problems where there's a variable somewhere in the exponent. For example, 3 to the x minus 2 equals 27. The key to most of these problems is first getting everything into the same base. Well, we know 27 is a power of 3, it's 3 cubed. So now we can rewrite the problem 3 to the x minus 2 equals 3 to the 3. That means that the two exponents have to be the same if we have the base. So that gives us x minus 2 equals 3, or x equals 5. Why don't you pause the video for a moment and take a look at that, make sure you understand it, and then we'll try one just a bit more difficult. Okay? You understand the last one? Alright. How about this? 2 to the power k plus 4 equals 8 to the power k. This one looks a little bit scarier, but think back at our rules. It's not that complicated. 8 is a power of 2. What power of 2 is it? It's 2 cubed. So that means 8 to the k power is equal to parentheses 2 to the third power close parentheses to the k power. Now if you remember our rule, 2 to the third power to the k power is equal to 2 to the power 3 times k. Because if you raise a power to a power, you multiply the exponents. Now we have the equation 2 to the power k plus 4 equals 2 to the power 3k. Now if we have the same base and the two powers are equal, then the exponents have to be equal. That means k plus 4 equals 3k. Subtract k from both sides, and we get 4 equals 2k. Divide both sides by 2, and we get k equals 2. Now let's go back and check our answer. 2 to the k plus 4, that's 2 to the 6. Well, 2 to the 6 is 2, 4, 8, 16, 32, 64. So, 2 to the 6 equals 64. What about 8 to the k? We said k was 2, and 8 squared is also equal to 64. 64 equals 64 is the kind of result we like to see.